Okay, kiddos, here's a little video lesson on projectile motion, how to calculate initial speed, initial vertical velocity, initial horizontal velocity, time to max height, maximum height, time in the air, range, that kind of thing. So the notes kind of go like this. In general, you will be figuring out something about the time, okay? So this is either time to max height or time in the air that you will be finding, and it's the vertical motion that determines that. So the fact that it's moving to the side has nothing to do with how long it is in the air, okay? So this is the formula that describes final velocity, initial velocity, acceleration, and time, and we use this formula to find time, and that's either time in the air or time to max height. And the acceleration due to gravity is always downward, so negative 9.8. And then initial velocity will always be the initial velocity in the vertical direction, which we sometimes call v sub y, which we get from SOHCAHTOA and a right triangle. Okay. So, yeah, maybe I'll work through an example here in a minute, but to figure out how high something goes, first you have to figure out how long it takes to get there, so we call that time to maximum height. So if you know the initial vertical velocity, you can then solve for time to maximum height. The final velocity, excuse me, in this situation is always 0, because when something goes in this parabolic path, okay, the fact that it's moving to the side doesn't matter. Up at the top of its path, so right up here, the vertical velocity is 0. Okay, so this is how you figure out, or this is the first step in figuring out how high something goes, or what is its maximum height. You find time, and then using this formula, and so this is the formula for basically how far something goes if it is accelerating. If it's not accelerating, and we were to just cover this up, you see it would be distance equals velocity times time, basically. So that's a formula that you're familiar with from a long time ago. Distance equals rate times time. But if it's accelerating, we need this additional term in there. So we have calculated how long it takes to get to its maximum height. We plug that value in for t, and we figure out how high it goes. So this is vertical position. Okay, so this still is dealing with vertical motion. This was dealing with vertical motion, not horizontal motion. So the initial velocity is the initial velocity in the vertical direction. The time is time to maximum height. If it's starting on the ground, we can say the initial position or initial height is 0. And again, don't forget the negative because this pulls downward. And this will be the final position, meaning the maximum height attained. All right, next page we're going to talk about finding how far something goes, or the range. So, how far does something go, or the range? Again, we first have to find time in the air. And again, for time in the air, we're going to use the vertical motion. So notice how I'm using a different formula to find time. Okay, before, to find time to maximum height, we used this. Final velocity equals initial velocity plus acceleration times time. And this formula will work if you know the initial velocity upward, okay, in the vertical direction, and you know the final velocity downward in the vertical direction. This will work. Acceleration would be negative 9.8, and you could find time, and that would be time in the air. And usually, these are just opposites. But this will always work, and this works for situations where it maybe starts and ends at a different height. Okay, those are the trickiest. So we're using this formula. We're talking about vertical motion, and what we're solving for is time. So we know where it starts and where it lands in terms of its vertical position or height. Initial position, 0. So this is if it is starting and stopping on flat ground, sort of like that. So initial position would be initial height, 0 on the ground. Final position would be final height, or 0, ends on the ground. Acceleration, negative 9.8 meters per second squared. And then initial velocity is initial velocity in the vertical direction. So you plug in and you solve for t. You're probably going to have to factor out a t, but other than that, it's pretty easy to solve. So this will work to find the total time in air when solving for the range. This will also work, okay, and in general, the initial upward vertical velocity is the opposite of the final vertical velocity. So if you get a question like this, you might want to try solving for t both ways just to make sure you get the same thing. Then, once you know the time, okay, and this is key, when you're figuring out how far the range, notice how I'm using just distance equals velocity times time, okay? And this is a key point here. When we're talking about the horizontal motion, okay, the velocity remains constant. It goes the same speed in the horizontal direction. Acceleration is 0 in the horizontal direction. So this is basically the same formula that we were using before to find maximum height, the 1/2 at squared formula, except that the acceleration is 0. So you can simplify your life by just multiplying velocity times time. The time will be the time in the air, and the velocity will be the velocity in the horizontal direction, v sub x. Okay, I hope that was helpful.